Okay, we are going over the Unit 9 review. This lesson, or this unit, I should say, has been short and sweet. So I hope you do really well on this test. It's not over a ton of material, and I don't think the material is too hard. So good luck. All right, number 1, find the domain and the range. Okay, so this is an exponential function. This happens to be a picture of exponential growth. And this graph goes forever to the left, forever to the right. Even if it was a picture of decay, it would go forever to the left, forever to the right, which means domain is all real numbers. So every time you see an exponential function, it's always going to go forever to the left, forever to the right, forever to the left, forever to the right. Even if it's flipped upside down, it will still go forever to the left, forever to the right. Okay, so I need a domain of all real numbers, which means those two are out. So both of these have the right domain. And then range. So these exponential functions have horizontal asymptotes. This one's horizontal asymptote is right here on top of the x-axis, which means this graph is getting ready to touch a y value of 0, but it's not going to get there, so I can't put an equal sign. And then the graph goes up, 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 which means the y's get greater. So that is answer choice B. All right, number 2. Which one is exponential growth? Well, for it to be exponential growth, whatever is under the exponent has to be greater than 1. So let's look at all the numbers that are, well, this one is not even exponential. To be exponential, you need the x as an exponent. See how the x is an exponent? The x is an exponent. This doesn't have x for an exponent. So this isn't even exponential. Okay, so whatever's under the exponent, for it to be growth, it has to be bigger than 1. That's not bigger than 1. That's not bigger than 1. But that is. And if you didn't realize it was bigger than 1, you could put 5 divided by 2 in your calculator, and you would see it's bigger than 1. So A's are winner, winner, chicken dinner. All right. So now there are a bunch of these that you need to know how to do. So with these problems, we're trying to get the bases to be the same. So whatever's under the exponent, that's the base, and we're trying to get it to the same. So we have to think about if I could raise 4 to a power to make 32, or if I could change this to a 2 and raise 2 to a power to get 4, and could I raise 2 to a power to get 32? So, you know, if you don't really know, you could start playing around. So you could try the 4 and see if you could get a 32 out of it. So 4 squared, no. 4 cubed, okay, too big. So the 4 is not going to work. So we have to figure out a different base. Well, I know that 4 is 2 squared. Well, could I get 32 out of a 2? So play around. 2 to the 4th, oh, not big enough. 2 to the 5th, bing, 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 bing. So I'm going to write these with a base of 2. So this 32, I'm going to rewrite as 2 to the 5th. And this 4, I'm going to write as 2 squared. So 2 to the 5th is the 32, and 2 squared is the 4. Okay, so now I'm going to recopy this exponent, and I'm going to put it in parentheses. And I'm going to recopy this exponent, and I'm going to put it in parentheses. So the way this works is if these two bases are the same, which they are, then the two exponents have to be the same. So this exponent has to be the same thing as this exponent. So my equation would be 2 times 2x plus 7 equals 5 times x plus 3. So hopefully that makes sense to you logically. If the bases are the same, then in order for them to equal, the exponents have to be the same. Okay, so we need to distribute to get rid of the parentheses. So 2 times 2x is 4x, and 2 times 7 is 14. Then I'm going to distribute the 5. 5 times x is 5x, and 5 times 3 is 15. I need to get my x's on the same side. It doesn't matter which one you move. I'm just going to move the smaller one. So to move a positive 4x, I do the opposite and subtract. And then the 14 would drop. The equals would drop. 5x minus 4x is 1x, or x. And then the plus 15 drops. Okay, so to get x by itself, I'm going to get rid of addition of 15. So I'm going to subtract 15 from both sides. And 14 minus 15 is negative 1. And that's my answer to number 3. I took a lot of room writing that problem. All right, number 4. All right, so when you see a fraction, that means you're going to have negative exponents. Well, I know 81 is 9 squared. Let's see if I can get 9 raised to some power to make 243. And if I can't, I'll do something different. Okay, so I know 9 squared is 81. So if it was 9 to the negative 2, it'd be 1 over 81. And if you didn't know that, when I put 9 to the negative 2 in there and math enter it, see how that's 1 over 81? Okay, so I'm going to give this a base of 9. Let's see if I can get 243 out of a 9. So 9 to the third, nope. And 9 squared, we know was too little. Okay, so 9's not going to work. So 3. Let's try 3. 3 to the fourth, that's going to make the 81. And to make it a fraction, it'd have to be 3 to the negative 4. So if you see a fraction, you need a negative exponent. Okay, and then let's try this. 3 to the sixth. Nope, too big. 3 to the fifth. There it is. So 243 we're going to write as 3 to the fifth. And the 81 was 3 to the fourth. And then because of the fraction, 3 to the negative fourth. Okay, so this guy is going to get rewritten as 3 to the negative 4. And this guy is going to get rewritten as 3 to the fifth. Okay, then I'm going to recopy the exponents. So this exponent's a t. I'm going to go ahead and put it in parentheses. And this exponent is t minus 2. Okay, so it's like this last one. If these two bases are the same, then that means the exponents must be the same. So this exponent has to equal this exponent. Okay, so let's write that down. This exponent, negative 4 times t, or negative 4t, has to equal this exponent, 5 times t minus 2. Okay, I'm going to distribute the 5. If I do that, I get 5t minus 10. I'm going to bring down my negative 4t. Now this time I'm not going to move the smaller t because he's already by himself. So I'm going to move the 5t over. So since it's a positive 5t, I have to subtract it. So these add to make a negative 9t. And then my negative 10 comes down. And then to undo multiplication, I divide. So I divide both sides by negative 9. And a negative divided by a negative makes a positive. So it's a positive 10 ninths, which is answer choice B. All right, number 5, same kind of thing. I need to make these the same base. All right, well, I know this is 8 squared, but I know 8 raised to nothing will make a 32. So let's see if a 4, nope, a 4 is not going to work. Let's try a 2. Okay, I'm going to try a base of 2. So 2 raised to the, let's try 6th. So that's 2 to the 6th. And 2 raised to the 5th. That's my 32. So 64 I'm going to write as 2 to the 6th. And 32 I'm going to write as 2 to the 5th. Okay, so this one is 2 to the 6th. This one is 2 to the 5th. And I'm going to put my less than. Okay, now I'm going to recopy the exponents. So this exponent of x, I'm going to recopy. And this exponent of x plus 2, I'm going to recopy. All right, so like the last two problems, if these bases are the same, then that must mean the exponents are the same. But instead of an equal sign, we're going to use a less than sign. Okay, So this exponent, 6 times x, or 6x, is going to be less than this exponent, 5 times x plus 2. All right, so let's distribute that 5 to get rid of the parentheses. So 5 times x is 5x, and 5 times 2 is 10. And then I'm going to drop my symbol and my 6x. I need to get my x's on the same side. Since he's alone, I'm going to move him over. So to move the positive 5x, I subtract it. 6x minus 5x is 1x, or x. Drop the symbol, drop the 10. And that's my answer. X is less than 10. And that is D. Okay, we're cruising. First page complete. All right. All right, number 6, a different kind of problem. Says, find the domain and range of this function. Okay, well, first of all, it's exponential because the x is an exponent. And I just said a little bit ago, the domain is always all real numbers if it's exponential. So I can get rid of C and I can get rid of D. Now, I'm going to graph it just so we can have a visual. So I'm going to go to y equals. I'm going to type my 3. Alpha y equals, oh, I probably wanted a parentheses there. Get rid of that. Okay, 3 parentheses, alpha y equals, enter. 1 on top, arrow down, 5 on bottom, right arrow out of it. Close the parentheses. Raise it to the power of x. That guy right there. Okay, hit graph. Okay, so I know you don't see arrows and you don't see this extremely well, but this goes forever to the left, forever to the right. Because there's nothing back behind it, the asymptote would be right here on top of the x-axis, which means this graph has a y value getting closer and closer to being 0. So the y is close, close, close to 0, and then the graph goes up, 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 which means the y is getting greater. So if that's the case, the answer is B. Okay, next one. All right, it says that the parent exponential function, f of x equals 2 to the x, has been transformed, and this is how it looks now. Okay, well, let me show you the parent. So 2 raised to the x. Here's the parent. This is what the parent looks like, and this is how he looks now. Okay, so the parent has a horizontal asymptote right here on top of the x-axis, which is y equals 0. Did this asymptote go up or down? It went up. It went up to right here, which looks like it went up 3. So let's see which equations go up 3. Well, all of them do. All of them have a plus 3 in the back, so they all go up 3. Okay, so that didn't do me any good. All right, now look at your picture here and then the transformation one. Does this look like this picture went left or right? It went right. If you compare it to the picture of this graph has shifted to the right. So which of these would make the graph go to the right? C. So remember, whenever you see something in parentheses, it goes left or right and always opposite of your thoughts. So the minus makes it go right. Okay, number 8. All right, so it says, which statement best describes the effects on the graph of f of x equals 2 to the x if f of x is replaced by all of this stuff? Okay, so as soon as we see a negative, I know it reflects over the x-axis. So this says reflects over y-axis, so A's out, because the negative in front is a reflection over the x-axis. Reflects over x-axis, okay. Reflects over x-axis, okay. Reflects over y-axis. Nope, out. Okay, if the number in front is bigger than 1, then I know that that is a stretch. So let's look. Vertically compressed, oh, I already crossed that one out. Vertically stretched by 2, yes. Vertically stretched by 2, yes, okay. All right, now in the parentheses, so now there's parentheses. So remember, parentheses is always left or right, but opposite of your thoughts. So plus makes it go left. So this graph is going to go left. So let's see, 3 to the left, 3 to the right. Oops, C's out, B's the winner. And of course, the -5 in the back makes the graph go down. Easy peasy lemon squeezy. We've been doing that stuff all year. Moving on. All right, number 9. All right, use the equation of the exponential function whose graph passes through the points 0, -2, and 2, -50 to find the value of y when x is -2. Okay, so we are going to use this equation right here. So this guy is called the y-intercept. Whenever your x value is 0, that's called a y-intercept. Well, the y-intercept is the initial value. And so A represents the initial value of something. So that means that -2 is the A. So where the A is, I'm going to put a -2. Now, this point that the graph goes through, well, the 2 is the x-coordinate, and this -50 that got like chopped off is the y-coordinate. So into the y, I'm going to put -50, and into the x, I'm going to put 2. So B is the guy I don't know, and I'm putting 2 into the x. All right, I'm going to solve this equation. So to get B by itself, I'm going to undo multiplication with division. So I'm going to divide both sides by -2. -50 divided by -2 makes 25. And then I'm going to bring down my B squared because that just makes 1. And then to get rid of a squared, we square root. And the square root of 25 is 5. Okay, so now I'm going to rewrite my equation. So I know that A is -2 because that's my initial value. It's my y-intercept. It's my starting point. So -2 goes into the A. I just found B to be 5. So I put 5 into the B. And then it says find the value of y when x is -2. Okay, so y is the guy I don't know, but I know x is -2. So I'm going to put -2 are my x's. And here comes my handy dandy calculator. I'm going to calculate this. Now, I could do this by hand, but I'm going to use my calculator. So -2 parentheses 5 raised to the -2. So that's your answer as a decimal, but you don't see any decimals over here. So I'm going to go math, enter, enter. So math, enter, enter. Math, enter, enter. And that will give you -2/25, which is C. Okay, I'm going to stop the video here, and I'm going to start back up at number 10.